Hello and welcome to this video. It's a pleasure for me to see you here and what we are talking about today. Today we want to talk about new security features inside the DevOps environment, and there we will go from the IDE down to the repositories and we'll see what different features we can offer here in this JFrog platform. And if you're interested in this, then you're right here. By the way, my name is Sven. I'm developer advocate for JFrog, and as you can see, I'm not in office. I'm out in the Swedish woods. I'm here in a national park. This is my base camp for tonight, and yeah, I will explore a little bit the area with my light package. So I will take you with me on a hiking trip, and during this, you will see a little bit from this area, and on the other side we will discuss a bunch of security related topics. By the way, if you like this outdoor theme and you want to see a little bit more about DevSecOps and cybersecurity, feel free to have a look at my YouTube channel, and I really would like to see you as my subscriber there. So, but long story short, meaning I will pack my stuff finally. So we'll pack the camera with me, and then we will start with a hike. So stay tuned. Okay, first topic, what we want to discuss is supply chain security. Supply chain security is a big thing now, and everybody's talking about, but what is supply chain security and what are the key factors that are changing the environment during the last, let's say, 2-3 years? And especially, we are now talking mid or end 2022, since we have this political thing in the East. What's changing here? So first of all, supply chain security in general is everything from the idea down to the product. So it means you have an idea, there's a concept phase, and you're organizing all the materials, third-party products, services, your own production, until it's delivered to the customer. So this is a whole supply chain, and that includes everything. And now we are having some changes inside the supply chain. So the supply chain itself is changing, or the way how the supply chain is attacked is changing. First of all, during the pandemic, a lot of things changed. A lot of companies pushed their employees to home office, and this means that this new environment was used to attack this infrastructure, or they attacked now this new infrastructure coming from this global things like a pandemic. So this is changing the world, global events or global things that are going on. And on the other side, we have this shift from pure money-driven attacks. I want to get some money, I'm stealing data, whatever things, to more and more political motivated attacks. Especially now, we saw that even small and medium business size companies that are working for big companies that are unfriendly, or if you're delivering to a country that is unfriendly declared from some other country, that you're not even attacked by individuals or hacker groups, that you're attacked by governments. And this is a big thing. Then on the other side, the big companies have enough money and resources to increase the security, there's defense, and it means that the pressure is pushed along the line through all the small and medium business size companies. Means that instead of attacking the big companies, they try to sneak in over the supply chain, and it means they're attacking these tiny companies that are delivering something to the big companies. So this is a whole supply chain thing. And we can see that even if it is not a governmental infrastructure, if we have these groups or individuals, even these groups are joining forces, sharing resources, sharing infrastructure, and this is increasing dramatically the quality of attacks. But what does it mean now for us inside the software supply chain security? Okay, now we're talking about software supply chain security, and it means from the whole supply chain security part, what is the software supply chain security? And the software supply chain security is more or less from I have source code, I'm implementing something, if I'm excluding the concept phase, and building some binaries out of it, and the binaries are pushed to production or as a library to some repository or whatever. So the main thing is, what are the elements I have, and the elements I can influence or have to deal with as software developer inside this software supply chain security. So first of all, we have source code. Okay, it's the basic, no? So we start typing, and what can happen here? It can be compromised. You can have some intentional bugs included by some developers, whatever. I'm not going to all these attacks in each stage. There's a very cool project called Salsa, and this is part from the Linux Foundation. It's an alpha stage, but it is a very good open source documentation project where you can see all the attacks against this, or a lot of attacks against this software supply chain security, and what are prominent examples, what you can do against it, and you will find some levels where you can see on which level you are and what would be the next best step to increase your security. I have on my YouTube channel a dedicated talk about the project Salsa, so check out this one if you're interested in more details. But back to the topic, for me as a software developer. So I have source code, then I'm pushing this to a Git repository. This is infrastructure. From this Git repository, it will be transferred to some build infrastructure. Build infrastructure can be compromised. Very prominent example is the SolarWinds hack. And from this build infrastructure, I have two paths more or less, consuming binaries from external repositories or external places, producing binaries and pushing this one to repositories back. So in the end, what do we have? We have source code, we have binaries, and we have infrastructure parts. The infrastructure part is more or less, do you have the resources to maintain and secure this stuff? Do you have the knowledge? Or are you using, for example, hosted environments? But the software developer itself has to deal every day with source code and the binaries. And this is exactly where we want to focus on now. So how to protect the source code and the binaries, and seeing what is the most prominent thing here. And this is where you as software developer should focus on source code and binaries, and if it is your responsibility, the infrastructure itself. So let's start. Okay, now, after I saw that as a software developer, I have to deal with source code and with binaries, the big question is, what is the bigger part, or what's the most important part? Okay, different question. The bigger part first. So we have source code. Even if you're writing 100,000 lines of code, if I'm counting all the lines of code from my dependencies, from my internal or external dependencies, mostly this amount of lines of code is way bigger, even if I'm just looking inside my application. If I'm looking at the whole tech stack, for example, the operating system, then I'm just writing a few lines of configuration and the rest are binaries. And if I'm going through the Docker layer, then it starts even with a from statement with a dependency to something. So it means altogether, the amount of lines of code from dependency are mostly way higher than the amount of my own self-written lines of code. It means in the whole thing, binaries are the biggest part compared to stuff I'm writing by myself. Okay, binaries everywhere now. So what is in the background? So how to organize these binaries, how to make sure that you have the right binary, and so on and so on. And this means that in every layer you will have, for the management of binaries, all as a dependency manager. So in Java you have this Maven. Maven is the dependency manager to organize the PDF library and all this stuff. You have a version, you have a binary, you have a location, you have a resolver strategy. And the same is for the operating system. You're not writing your own management to store the versions. So you have a Debian package manager. Docker, you have this Docker Hub as a central repository. You have something for Terraform scripts, you have, and so on and so on. So the whole thing is more or less, for every technology, you have something to manage binaries with dependencies, with resolver strategies, with versioning and all this stuff. And their dependencies, or transitive dependencies, that's an important thing. And what the most people are forgetting is they have no repository for their own stuff like compiler, IDE, and so on. So thinking in general about a release, it would make sense to have a release that's including source code, all binaries, including the whole tech stack in a version. So that would be a release, a full release. So long story short, meaning is every technology will provide you with some kind of dependency manager. And the knowledge and the handling of dependency managers, this is one of the key points if you want to secure your software supply chain security. All these dependency managers are talking about some kind of repository, and we have different kinds of repository. And the first one I want to highlight is a local repository. A local repository could be, for example, the local .m2 folder for your Maven dependencies. It's on your disk, you have full access through it, you can manipulate it. It's your responsibility to make sure that inside this repository you will not find compromised binaries you're using for your own builds. So it's your responsibility there, more or less. On the other side, if you are talking about dependency manager or in repository manager like Artifactory, then the local repository means that you have a repository inside the instance of this repository manager. So a local repository in Artifactory is the repository that is managed and controlled by Artifactory. And the key point here is in these local repositories, mostly you have read and write access, you have the possibility or the responsibility to maintain it in terms of making sure that no compromised stuff is in. You have to clean it up, you have to secure it, and so on and so on. So local repositories are fully under your control, but under your responsibility to harden it in the same way. If you have local repositories, then we have remote repositories as well. And it's really, remote repositories are mostly something like Docker Hub, Maven Central, or other central repositories that are not under your control. It could be from a third party, from a different company, whatever. It is a repository that you haven't under control. You can just request stuff out from this. You have to trust that the binaries are not compromised there, that the security there is right implemented, and so on and so on. And you're just requesting it. Remote repositories in your Artifactory instance is a repository that's a virtual proxy against the original remote repository. So it's not good that everybody is directly asking the original remote repository like Docker Hub or Maven Central, because then everybody has to implement the security scans on its own machine as well. So it makes sense to have this remote repository inside Artifactory. This virtual proxy is requesting from Maven Central, then we can implement all the security stuff there, and then it's delivered through you. So, and so this is the part remote repository. Okay, we had local, we had remote repositories. The last I want to highlight here is a virtual repository. A virtual repository is a composite of local, remote, and other virtual repositories. And inside Artifactory, virtual repositories are very, very lightweight. So, and we have a very strong deduplication mechanism in local, remote, and virtual repositories, so in the whole platform. So you can build a bunch of virtual repositories, and what you can do here is you can hide external structures, naming strategies, mirroring strategies, caching strategies, whatever it's from outside. So every technology will have its own best practice or implementation, like Debian is different as Maven and so on. And you have a central place where you can maintain access to all these different mirrors and caches, so that inside your own company or inside your own strategy, you have your own naming schema. You don't have this naming schema bleeding in, and you can maintain at a single point all these different strategies to deal with mirrors and caches and all this stuff. So then we have two very important things I want to highlight here in a short with some words. Is we have fully role-based access at this virtual repository in the same way as for local and remote repositories. In a way, if I have in a virtual repository 3 repositories, A, B, and C, and I have two persons. Person A is the first person is able to see the repository A and B, and the other one is able to see the content from B and C. And if I'm mixing A, B, and C, all repositories in one virtual one, and the first person is checking what's the content, he will see just A and B, and the second person will just see B and C. And another thing that's very interesting is that we have this default deployment repository. So if I'm pushing stuff to the virtual repository, it will be redirected to the default deployment repository. With this, we have a few benefits. First of all, I can hide all different security levels. I can hide all these different maintenance levels like mirrors and caches and whatever. I can maintain this in a central place, and the whole project structure is easy because it's just talking to one repository and not two different repositories. There's only one repository. So all the attacks that are going over old configurations or forgotten external update configurations about updates and all this stuff, it's not happening because you have just one definition of a repository here. So we saw that binaries are the most prominent thing, and all binaries are more or less consumed or managed by repositories and dependency managers, and these repositories, how to scan these repositories. We have one mechanism, it's called policies and watches, and here you have these policies. Policies are atomic rules where you can declare what will happen if I find something. So for example, I find a binary inside this or inside the binary I will find a vulnerability with a CVSS score 7.5. Then if you find something between 7.5 and 10, write an email or block and download or break a build or whatever, start a webhook. So you can define what should happen if you find something. That's the first thing. With these policies, what you can do is you can describe more or less, if you're so compliance documents, chapter by chapter, you can create mapping policies or whatever your structure is. On the other side, to identify now how to connect it to the repository, for this you need watches. Watches are the combination between policies on one side, so what should happen, and on the other side, what repository you want to check. Then you have, for example, a watch that's scanning a bunch of Docker repositories or a combination of Docker and Maven repositories or project, whatever. And then you can see what vulnerabilities are in. So you will find these watches inside the X-ray menu, and then this watch is changing the content always if, or it will update it if the vulnerability database will have an update. One of the included repositories will have a change in terms of something deleted, changed, or updated, pushed through, or if you're manually triggering the recheck or the rescan of this repository. So this is a thing that is more or less a constant view, or it's a view on a bunch of repositories. And with these watches, you will get this table of vulnerabilities, and then you can start working with this information about the vulnerabilities itself. So the first concept is policies and watches. Sometimes you just want to have an overview of what vulnerabilities are in this repository, this combination of repositories, and you don't want to change it. So for this, we have this concept of a vulnerability report. It's a one-time snapshot. It's not changing anymore, so sometimes you need it for just a talk. So I want to see, okay, what's going on here, so to analyze it. Sometimes you need it for documentation. So at this date and time, we were aware of the following vulnerabilities, because this report is not changing. It's really a snapshot of this date and time. And it's optimized for storing the report, exporting it as PDF, CVS, whatever, XML, whatever data you want to have, so that you can consume or work with this data. And very easy to create. You're just selecting the repositories, selecting what you will see, and say go, and then it's a one-time snapshot. So this is called vulnerabilities reports. The next thing I want to explain is the concept of on-demand scanning. On-demand scanning is something that is used to scan binaries you don't know before you're pushing it into your own infrastructure. And what would be an example? For example, you're working on Docker image, you're creating Docker image, and you want to make sure that this, you're composing it from different external resources, or you will get a Docker image from your, I don't know, third party, someone. And you have two choices. You can take this Docker image and push it into your infrastructure to get it scanned, but then you have something maybe with malicious code packages or with vulnerabilities already inside your infrastructure. But on the other side, you can do the same scan on your machine, on your local machine. So you're creating this Docker image, you're scanning this Docker image, and then you see, here, this vulnerability is in. The report that will be created during this on-demand scan will be pushed to Artifactory so that this one is persistent or persisted, and then you can discuss with your colleagues, or you can analyze it or whatever. So use it for documentation purpose. But the main concept here is you have the full potential of X-ray on your local machine or the machine that you're using as a scan machine or whatever you want to use. You can use a full X-ray power locally, and then this report will be pushed to Artifactory for documentation purpose, and you can decide if you want to push this binary inside your infrastructure, yes or no. So not always the best concept, not always the worst concept. It's a very powerful concept, and yeah, it's the first line of defense against stuff that is coming from outside. Okay, next concept I want to highlight here is the concept of build info and SBOM. So we learned, or since the SolarWinds hack and the executive order of cybersecurity from the US President, Mr. Biden, we know that there is this concept called SBOM, the software bills of material. And everything, so what's inside? Inside this software bills of material, you will find all dependencies and their dependencies, so the whole dependency tree with version, fingerprint, and all this stuff, so that you know what are the components that are used or that are inside this environment here. And we know it since a long time before it's called SBOM, and we called it build info. And build info is a superset of SBOM, and you will find inside additional information about environments, about the build agent, name, operating system, whatever you want to store. So the good thing is, if you have this build info, so the context in which this binary was created, then you can analyze later if after something happened or if something is happening, you can analyze, constantly, if build agent number 3 is building the binary, something strange is going on. So build info is a superset of SBOM. You can generate an SBOM out of build info in these two different specs that are more or less in the market. And you can create this build info locally with command line. You can create it inside your build environment. You can decide what information should be stored inside this build information, so that you are building the information package around the binary that fits your needs. And this is a very powerful concept, and it's working with a command line interface, with plugins for the CI environments, inside pipelines, and so on and so on. So there are many ways to create this context or to store the context during the creation of a binary. As a developer, you are working quite often inside an IDE, and why not giving all the information inside the IDE instead of just holding it inside your CI environment? So what are the benefits and why you should do it and how it works? The JFrog IDE plugin, you can freely download it in the most IDE or plugin stores for IntelliJ, VS Code, Eclipse, and whatever. And then you're connecting to the JFrog platform. Could be a free tier, enterprise, whatever. You need an platform, JFrog platform. And then what you will have is you will get all the vulnerability information straight inside your IDE. That means if you're coding Java with Maven, then you're adding a Maven dependency because you need a PDF library or whatever, and then you are just adding this dependency. In this moment, you will get all the transitive dependencies that are coming with this dependency. So you will see the whole dependency tree from all dependencies, and then you will get the vulnerability information and additionally the compliance information. But you will get all the vulnerability information, and then you can start working against vulnerabilities, or you can improve your security without even coding one line of code. So instead of just adding a dependency, working with it, doing a commit, pushing it to the CI environment, getting feedback after a bunch of minutes, you will see immediately what is going on with the vulnerability. So it will immediately speed up your workflow, and it's a very agile approach because you're not even writing one line of code, you're just adding the dependency, you're getting feedback, you have the information, you can react immediately, and and this is saving a lot of time. So the IDE plugin is a very good point. So if you have the possibility, bring this information inside your IDE so that you're not losing and wasting time. So the information that is inside X-Ray makes sense to have it in different places, not only inside the CI environment, not only inside your IDE plugin, for example, but tools like Docker Desktop, for example, make sense to bring this vulnerability information in this as well. So we have this JFrog Docker Desktop extension. You can download it over this plugin store, this extension store inside Docker Desktop. And here, if you are playing around with your Docker images, you're creating a new one, you're fetching one or whatever, you can analyze it with the fault capabilities of X-ray. So you will get the long list of vulnerabilities, CVSS information, malicious code package, and so on and so on. And this straight inside your Docker Desktop environment. So you don't need to switch to an IDE or to command line. If Docker Desktop is one of your tools you're working with, then you will get the vulnerability information there as well. So you're not losing time, or you don't have to switch between tools. So it really makes sense to see or to check how many different points you have where you will need the same vulnerability information just to be more productive, and you're not switching between tools, or you don't have to, so that you're not losing time. So it's really a very efficient way. So have a look at this Docker Desktop extension, and you will see that after scanning an image, you will get all the vulnerabilities and additional information listed inside your Docker Desktop environment. So everybody knows it. We are searching for an open source library. We are searching for an open source project. We are searching for some functionalities. We are able to find something. We are checking the home page. We are checking maybe the API. It looks good, and there is a new version, and it's available in Maven Central or whatever tool you're using. And then there's this big question about operational risk. What is operational risk? Operational risk is the risk if this open source component you're using or adding to the project will be active enough or will be healthy enough so that you can trust that this, or most likely trust that this project will be maintained during the time you're using it. So what are the components inside operational risk? How often you will get commits, how often you will get updates, how fast vulnerabilities are fixed, bugs are fixed, how many maintainers. So the whole thing about how healthy this project is. And if you're checking this for your direct dependencies, and then for the transitive dependencies, if you're doing this on a manual base, and it's just a huge amount of work, and this is you're not able to do it on a daily basis. Because if a project is healthy right now, it's very good to know if this is healthy in a few months as well, because you're not checking the whole time if something is changing. So if a project comes in healthy or with a higher risk because there is no new update, there is no bug fixing anymore, then you should get a highlight or should get an alarm so that this is done. So we have this operational risk. By the way, if you want to know more about the operational risk itself, so the details and all this stuff, then check out my YouTube channel. I have some security shorts, and operational risk is one of them. So there I'm explaining all the params and all this stuff. Otherwise, check out the original documentation on the JFrog platform. There you will find all the different params and what it means if it is red or green inside the operational risk tab. So you will find the operational risk inside the platform for all the dependencies you're using inside your project. And it's worth to have a look at it, because it's good to know if something is healthy, not only from the technical point of view in terms of features, but from the maintenance, if you start using it in your long-running projects. So we have this extended security information, because if you have an vulnerability and you know there's a CVE number, whatever, okay, it's an identity, you will get a CVSS value. Okay, I will cover a little bit more the CVS stuff in a few minutes, but if you have just this information, then it's not enough to identify, is this critical, how to deal with this, what is this exactly. So, and for this, we have this extended security information. It means we will give you reference documentation, the information about the CVSS vector itself. We will give you remediation mitigation information for a bunch of vulnerabilities, and so on and so on. So you will have here not only a description, you will see what components are affected by this vulnerability, what components are using this one, or this component is using the following components. So you see the dependency tree, or the impact graph. It's better the impact graph. And You will get links to additional documentation. Sometimes you have even source code snips to show what is critical invocation, or the critical way of invocation, or how to get rid of it, how to make it safe again. So this remediation, mitigation information is part of this as well. So it's really worth to look at this information. So if you have a vulnerability, to identify, is this critical for me? What can I do against it? If there's a patch, if there's additional documentation, is there whatever, check out this extended vulnerability information. It's nearby the vulnerabilities, mostly on the right side, and then you can navigate through. So have a look there, and it will help you to fight against these vulnerabilities inside your project. Okay, the next thing I want to explain is the value of this CVSS value and the CVE value. You will find this CVSS values and CVE value inside the JFrog platform nearby the vulnerability. And what does it mean? So the CVSS itself is a number between 0 and 10, and it's something 3.5 or 7 dot whatever. And it's a description how bad this vulnerability is. The CVSS value is based on three different metrics. I'm not covering all the metric details here because I have not enough time for this, but on my YouTube channel you are able to find a very extended version of the CVSS metrics and the explanation how you can calculate it and how to read the whole CVSS vector. But the basic thing here is we have three metrics. It's a base score, it's a temporal metric, and it's an environmental metric. So the base metric is the description how bad the vulnerability is. It's a worst case description. The temporal metric is more or less a description over the time. If there's a fix, if there's a bug fix, if there's a workaround, the quality of the vulnerability, is there a virus, a full automated source code available, or just a proof of concept, and so on and so on. And then there is this environmental metric, and the environmental metric is mostly interesting for you if you want to calibrate the CVSS value for your environment to see if the CVSS value is critical for you, yes or no. So inside the JFrog platform, what you will find is a base score. So the base score is a worst case description of this vulnerability. And this means that if you're clicking on this value, we have it in different, I think, CVSS2 and CVSS 3.1. And if you're clicking on this number, you will get a detailed list. So you will see the vector of this base metric. And then you see, okay, it's based on a network attack and or all this stuff. So with this information, you are able to calibrate a little bit what does it mean for you. And it's interesting for you to understand the impact of this vulnerability, so to learn more about this one. Additionally to the CVSS value, you will get the extended security information, but there is a CVE number. The CVE number is the identity of this vulnerability. So it's an ID of the vulnerability. And if you're searching with this CVE in Google or whatever, so inside the internet, then you will find additional information. So you will find different blogs and technical descriptions, all this stuff. So these two values are important for you. The CVSS value is the base metric, and the possibility to see how this base vector is created to get an idea if this is really critical for you. And the other thing is the CVE value. So additionally to the extended security information we are delivering inside the platform, you can just search in the internet for more information, documentation, so that you can work with this vulnerability. So for you, it's basic information you need to deal with vulnerabilities in your whole tech stack, to identify what is the best action on your side, what should you do, and to have more details and more information about the impact of this vulnerability. The next feature I want to highlight is a contextual analysis. Contextual analysis is a feature that will help you to identify if a vulnerability is really critical for you or not. So what does it mean? For example, vulnerabilities, they need something around them. So you need to invoke a special method, or you need some kind of configuration, an open port or whatever. So there is not only the vulnerability critical, the vulnerability is critical if there is something around that makes it possible to use this vulnerability. And one prominent example is Log4j shell, for example. There was this very, very high critical vulnerability, but if you have something in your configuration, if you're not using this part of Log4j or whatever, this vulnerability was not really critical. And then CVSS core 10 maybe is for you just a CVSS core 3 or maybe 0 or whatever. So what does it mean? The contextual analyzer will analyze the text that's available for X-ray inside the JFrog platform. So for example, the Docker image or the jar or whatever. And then inside this binary, it will search for how this library that is contains the vulnerability or malicious code is used or not. So it's not only the vulnerabilities, it's malicious code detection as well. I will cover this a little bit later, but it will just see, okay, are you invoking this method? Yes, no. Are you having this piece of configuration activated? Yes or no. So the whole stack will be scanned and will give you the possibility to divide the full amount of vulnerabilities in more or less two groups. Vulnerabilities that can be misused on your system and vulnerabilities that are not able to be misused in your system. And this will give you the possibility to focus just on really the important or the high critical vulnerabilities instead of just focusing on all of them. So the remediation mitigation information, the contextual analyzers that will help you to prioritize the way you're fighting against the vulnerabilities. The next feature I want to highlight is this JFrog secrets detection. So what are secrets? Secrets are username password configurations, API tokens that are stored in environment variables or in config files and so on and so on. It could be something like an API key inside your source code, if it is hard-coded inside your application, and so on and so on. So we have so many different ways to store secrets and to deal with secrets that it's most likely that you will have some weak parts inside your system. For example, if you're grabbing default operating system image in Docker, then it could be that you have old SSL keys there, or you have additional default users with default passwords inside your configurations, and it's worth to scan for them and try to remove all this stuff. So the secrets detection will go through the whole tech layer that is offered to this analysis part. It could be just a jar, it could be a whole Docker image, and then it will give you all the detailed information of secrets that are found by X-ray. Then you can start hunting against it. For example, if you have this environment variable, this API access token inside your Docker image declared, and it's a real API key there, or it's referencing a text file, and inside this text file, this API key is available, then someone else can extract it and can misuse it. And that's more or less a basic idea behind it. So check out for the feature secrets detection and start hardening your bugs. Start hardening your Docker images or your environment. One new feature in the JFrog platform is a malicious code detection, and for this you need to understand a little bit the difference between vulnerabilities and malicious codes. So vulnerabilities, intentional or unintentional vulnerabilities, are more or less software bugs. So it's something that you try to misuse, for example, unsafe reading of files, and then you can start doing some stuff. So vulnerabilities will get CVEs mostly, so that you have an identity and then you have a reference documentation and all this stuff about this vulnerability. But malicious code is something that is not identified, or it's not represented by an CVE. There's no identity. These packages are mostly in general infected, and what you need to understand is here how obfuscating techniques are working, what are security payloads. So malicious code would be something like there is one line inside the source code that is hex64 encoded, and if you're reading it as a machine, you will see, here I'm calling a web service, or I'm sending some data, or I'm starting a binary, or whatever. So it really depends what this malicious package want to do. And if you want to know more about malicious packages, security payloads, obfuscating techniques, and stuff like this, then check out my YouTube channel. I have a dedicated talk about this one, where I'm going through all the details. But what we can see here at JFrog is that we have some basic technique, or some base structures that are mostly used in these malicious packages, like this encoding, obfuscating techniques and calls and all this stuff. And so with X-ray, we can start scanning for exactly these patterns to identify this one, to give you an idea if there is some malicious part in, yes or no. So, and this for a bunch of open source projects is part of the X-ray database, and the malicious code detection is a very helpful feature to give you the possibility to identify these malicious packages and start digging there a little bit deeper and hunting them. So I'm back. I'm back here near my base camp. There the base camp. I put my backpack there already, and now I'm a little bit in this area before I start cooking my stuff. And yeah, so one service I really want to highlight is a services exposure detection. So let's assume you're configuring or planning or deploying your infrastructure with Terraform. Then you have different microservices, and a few of them are the interface to the outside world. So this is what the customer will access and go through. And then there's a bunch of services behind. So these are normally called internal services or hidden services or whatever service. But this is more or less for the internal usage. So let's assume that you have a misconfiguration and this internal service will be accessible from outside. Then this can be a big security hole. And to identify this one, you will get now help from the JFrog platform. If you're scanning, then you will get this services exposure detection. So it means you will get information what service could be exposed or what service can be reached from outside, so that you can start working against this and yeah, fix it, because you don't want to have internal service exported to the outside. Okay, so this is service exposure detection. Okay, application exposure detection. This is focusing on one application, so not a bunch of microservices, but really on one microservice itself. So if there's something that can be misused, this could be a bad default configuration, it could be a bad usage of libraries, of functions, it could be I don't know, open ports of the configuration, and so on and so on. So you will check here the whole application and try to identify the context of this application and checking against best practices and against security holes. So do I have vulnerabilities in? Can I access this vulnerability? Can I misuse different application functionalities? I'm just configuring the functionality I want to export and not all the defaults left and right. So a bunch of stuff will give you, or it's a bunch of information that you get about the application itself, so that you can make sure that you're not exposing stuff that should be deactivated or not accessible, and so on and so on. So that's called application exposure detection. So this was a lot of stuff in this webinar, and you saw a lot of stuff around how you can connect with Web UI, or how you can consume and get the security information via Web UI inside the IDE with the IDE plugin on command line interface, Docker desktop extension, and more and more. So all this together, you can try it by yourself. We have a free tier with limited security features, but unlimited in runtime. Or we have an enterprise trial where you can get all the security features, but I think a few days or a week or so. It's time limited. So on the other side, if you have in your company an Artifactory and X-ray already, just connect and you can start immediately. And if you want to have some hands-on experience, register for one of my free workshops. If you want to have more detailed information about some topics, check out, we have different webinars coming up with specialized topics, so you can register there to get these webinars as well. But if you want to connect to me, check out LinkedIn, Twitter, whatever, YouTube. Please don't use email. But I have a YouTube channel, two of them, a German one and an English one. If you want to have the English one, make sure that you are subscribing the right one, and there you will find a lot of cybersecurity videos in the outdoor style. And I really would like to see you as my new subscriber. Okay, so whatever day and time it is, have fun. What I'm doing now? Well, I will just go down there. There's a lake, and there I will make my fire, cook some food for tonight, and then I will go into my bivy tent and will sleep immediately. So it was a long day for me, and tomorrow I will go to the next place. And yeah, so this is 1 week of hike, and I'm really looking forward to it. Okay, so I'm done for today. You got all the information. I hope you enjoyed it. Stay safe and see you